We've spent a few days now talking about momentum. On the first day, last Thursday, we talked about momentum of an object that was moving at a constant speed. The momentum wasn't changing. Well, then we started talking about momentum after acceleration. That involved a change in momentum. Although we didn't quantify the change in momentum, we just found the final momentum. Today, I want to quantify the change in momentum. We're going to define a new concept called impulse. And we're going to define that quite simply as the change in momentum experienced by an object. The gain in momentum, the loss of momentum experienced by an object. Now, if I wanted to identify the factors that would cause an impulse, or cause a gain, or a loss for that matter, in momentum, what do you think they would be? I'm thinking of two in particular. What's one of those two things that would cause an object to, let's say, gain momentum? Same thing would cause an object to lose momentum, but let's just say gain. Yep. A force, yeah. If you want something to speed up and therefore gain momentum, or for that matter, slow down and therefore lose momentum, then you got to push it or pull it. You have to apply a force on it. Force is necessary to cause a change in momentum. Now, what's the other factor? No, not acceleration. Acceleration is directly related to force, which means that when you have a force, you have that acceleration, right? What's the other one? Time, yeah. The longer you apply the force for, the more you're going to change the momentum of the object by. So impulse, which is the change in momentum, is dependent upon two things: force and the amount of time that you apply the force for. Now, force is a vector times a scalar. When you multiply a vector by a scalar, force and time together, you're going to get a vector, which should make sense, right? Because if impulse is change in momentum and momentum is a vector, then impulse, of course, is going to be a vector. So however you think of it, if you think of it in terms of force being a vector, if you think of it in terms of momentum being a vector, nevertheless, either way you think of it, impulse is going to be a vector. Now, because it's a vector, it has a sign associated with it, positive or negative. It can be a little bit tricky, though, the meaning of the positive or negative. Impulse or change in momentum is positive in two situations, actually. I only have one written down, so I'm going to pencil in the other one here in a second. Impulse or change in momentum is positive if you gain momentum in the positive direction. What do I mean by that? A car is going to the north and it speeds up. It's gained momentum going in the positive direction. You're walking to the east and you're speeding up. You're gaining momentum in the positive direction. A positive impulse when you gain momentum in the positive direction. Now, there is one other situation that I'm going to have to pencil in here because I didn't put in those notes. One other situation where you can have a positive impulse as well. What do you think it is? Gain momentum in the positive direction. Tanner? Yep, yes, if you lose momentum in the negative direction. If I drop a ball, it's falling in the negative direction, right? Downward. But it's speeding up. Okay, that's not losing momentum in the negative direction. That's gaining momentum in the negative direction. But when it hits the ground, what happens to it? It slows down. Okay, that's losing momentum in the downward direction. That's a positive impulse. When you speed up or gain momentum in the positive direction, when you slow down or lose momentum in the negative direction, either one of those is a positive impulse. So let me circle this in blue and say and, or let's say or actually, lose momentum in the negative direction. Now, what about a negative impulse? What about a negative impulse or a negative change in momentum? If we gain momentum in the positive direction, that's positive impulse. If you lose momentum in the negative direction, that's a positive impulse. When do you get a negative impulse? Yeah, Tanner? Yes, when we lose momentum in the positive direction. But there is one more situation where we can have a negative impulse as well, and that would be when we gain momentum in the negative direction. So if we're looking at that rock or that ball falling again, not the collision with the ground as it slows down, but as it's falling due to gravity, as it accelerates, as it speeds up in the downward direction, it's gaining momentum in the negative direction. Hey, that would be a negative impulse. Now, we're going to derive an equation here for impulse using one of Newton's laws, Newton's second law, actually. You guys remember Newton's first law from last year? It's called the law of inertia. Object at rest will stay at rest until acted upon by an unbalanced force. Object in motion will stay in motion, straight line, constant speed, until acted upon by an unbalanced force. Remember the third law? Yeah, equal and opposites. If object A applies a force on object B will apply an equal and opposite force on object A. Newton's second law was that mathematical law, basically, that equation, F is equal to m times A. We're going to use that law in order to derive, in a relatively easy way, the equation that you see on our data sheet for impulse. We're going to say F is equal to m times A. Force is equal to mass times acceleration. Now, I'm going to replace A, the acceleration, with delta V over delta T. I can do that, right? Is that okay? Mathematically sound? Sure it is. So what I'm going to do here now, one more step, take the T up to the other side by multiplying, and I'm going to end up with F times T is equal to m times delta V. Now, let me ask you a quick question. M times V is what? M times V, not m times delta V. M times V is what? Momentum. Okay, if mv is momentum, m times delta V, or change in V, is change in momentum, which is impulse. So we've just written an equation for impulse. M times delta V is impulse. Well, then F times T must be impulse as well. Let's write out a delta P in front of this. That's going to be my symbol for impulse, F times delta T. Oh, sorry, yeah, delta P. So impulse is equal to F times T, and it's also equal to m times delta V. Now, I'm going to circle this in red. The reason I'm going to circle that in red is because that's what appears on our data sheet. Down here in the bottom left-hand corner, F times T is equal to m times delta V. For whatever reason, they don't tell us that that's impulse. You have to recognize that. I would, on your data sheet, if I was you, pencil in delta P or the word impulse to remind you that that's what that is. Impulse is equal to F times T, but it's also equal to m times delta V because those two terms are equal to each other. Okay, let's have a look at one example, example number one. It's in the package that I handed out to you on the first day. It says a 1,200 kilogram car was originally traveling at 25 to the north. 35 seconds later, the car is traveling at 10 to the south. Right away, I see this north and south thing. Draw attention to that. Reminds me that something's going to be positive, something's going to be negative. Unless we're talking about kinetic energy, then it doesn't matter, right? But if we're talking about momentum or impulse, it does. Determine the impulse experienced by the car over the 35 seconds. My mass is 1,200 kilograms. What's VI? The initial velocity, what is it? 25 meters per second. Positive? Is it positive or negative? Yeah, we'll make it positive. North is positive, usually. What's VF? Yeah, it's negative 10. Watch that, right? It's south, so like if you make it 10, it's like, oh, that's just a small little mistake. That's not going to matter too much. Yeah, it's going to matter a lot, actually. You don't make it negative, this will be wrong. And on a multiple choice test, that means your question is just wrong. There's no part marks. for just leaving out a negative, right? In a multiple choice. In your written test, there would be, but in a multiple choice, there wouldn't be. We also have a time here of 35 seconds, so let's write that in. Now, you saw a minute ago that impulse is equal to F times delta t, and you also saw that impulse was equal to m times delta v. Although those two equations were combined, we know that impulse is equal to both of those. Which one do you think makes sense to use? Ft or m delta v? Jake? Yeah. Yeah, I agree, m delta v. Now, having said that, if you try this, it's not wrong. You're just going to not get the answer. Try again. We're going to say delta p is equal to m times delta v. 1,200 kilograms times Vf minus Cvi. Now be careful here. Vf is negative 10. Subtract 25. Negative 10, subtract 25. When we do that, we end up getting negative 4.20 times 10 to the 4. Now, what are the units for impulse, you think? Yeah, I was thinking you were going to say kilograms meters per second, which would be correct because that's momentum. But remember that impulse is equal to F times t as well. So we can now use Newton seconds if we wish for both momentum and impulse. Kilograms meters per second is still correct, but now so is Newton seconds. Let's do B then, we'll take a break here. B says, determine the force required to change the car's velocity from its initial value to its final value. The force. Listen, there was no question in question A that we're going to do impulse, right? Because it said, what's the impulse? Like, it doesn't mean the question is easy, but it doesn't take rocket scientists to figure out that we're going to use impulse when the question says, what's the impulse? Question B, this is a little more subtle, but I'm going to point out to you this. When I see force and time in the same question, when I see force and time in the same question, this is what I'm going to do, impulse. It's not the only way to do a question. It's not. But it's a nice, tidy, efficient way to do a force-time question when you have impulse. So let's now say delta P is equal to F times delta T. We just solved for the impulse. And we're going to divide that by the time, which was 35.0 seconds. When we do that, we get negative 1.20 times 10 to the 3 newtons. After your break, you're going to come back and I want you to work on worksheet number 2, questions 1 to 8. There's 9 questions on the sheet, but I don't want you to do all 9 of them. I just want you to do number 1 to 8.